You are watching the 6.12 lesson video on Quadratic Applications Day 1. So what this means is we are going to be given our quadratic functions in context. So in context means there's going to be a situation, so lots of words. And what we want to try to do with questions like this is break them down to try to figure out how we can set up the quadratic, find out what information is useful, maybe some information is not, and then come up with an answer by solving our quadratics. And we're going to use all of the methods that we've been using in the past few days. So factoring, completing the square, quadratic formula, inverse operations. We have to decide which one works best. Okay, so number one, John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x equals 60 plus 5x. And then Sarah's total amount is given by the function g of x is equal to x squared plus 46. Okay, so right away I'm noticing that f of x and g of x are probably important. They gave us functions. And then it asks us after how many weeks, x, will they have the same amount of money saved? And then another big thing that we need to address here is explain how you arrived at your answer. Okay, so another thing that's important other than the functions, other than the fact that they told us x equals weeks, and you know what? Let's just write that out. I think that's really helpful. So even if they tell us what the variable is, I like to write it because it helps me to see what I'm actually looking for in the end. What else is important here? Well, they say after how many weeks will they have the same amount of money? So the same in math means equal. So we're talking about we're talking about both John and Sarah. So we want to know when John equals Sarah, or more importantly, when f of x equals g of x. And we know that f of x is 60 plus 5x, and g of x is equal to x squared plus 46. So immediately we need to think to ourselves, is this quadratic or linear? And we know it's quadratic because you got it, there's an x squared. So what do? Yes, you are right. We set it equal to 0. So I'm going to move everything over to the right-hand side because I see that I have a positive x squared here. So if I subtract away 60 and 5x from both sides, it looks like, well, I'm going to subtract away the 5x off to the side, but when I write it, I'm going to be careful. So 0 is going to equal x squared minus 5x, and then 46 minus 60, what is that, 14? Minus 14. Okay, so now we have our quadratic set equal to 0. I always try to solve it by factoring. So I'm going to try to see if the box method works for me, but some of you have broken away from the box method and are actually able to factor by thinking, hey, x times x will give me this x squared term. What times what will give me negative 14, but they also have to add to 5. So I know that 7 and 2 multiply to 14, and if I want to, I can play around with my signs. I already know that the signs have to be different because it's a negative 14, and I need to make my 7 bigger because when I add them, that will work. Some of you will do the box method off to the side, and I'm totally cool with that. If you weren't able to do this, just either pull out a separate piece of paper, do the box method off to the side, but either way, we should end up with this. And then, you know what, I'm running out of room. I think I can squeeze it in here. What do you think? X minus 7 is equal to 0, and x plus 2 equals 0. So we get x is equal to negative 2. Well, that doesn't make sense. And x is equal to 7. Now, why would the negative 2 not make sense? Well, we're dealing with the amount of weeks. So we can't have negative weeks. So after 7 weeks, they will have the same amount of money. And I'm going to bubble that because this is my final answer. And the last piece is to explain. So in red is my explanation. I set the two functions equal to each other, solved for x, and kept the positive solution. So we just need to explain, we want to talk about our process on how we got our answer, and that is exactly what they're looking for with an explanation. Okay, number two, a landscaper is creating a rectangular flower bed, all right, rectangular flower bed, such that the width is half of the length. Okay, some key important words. It tells us the area. The area is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. So immediately I'm thinking, okay, if these are quadratic questions and I have to round to the nearest tenth of a foot, I am not going to be able to factor this. Okay, so first thing, they're talking about a picture. I'm going to draw a rectangle, obviously. Okay, here's my rectangle. They told us the area, so the area is equal to 34 feet squared. They told us the width is half the length. So the width is half the length. So we could do this in a couple of ways. So the width is half the length. So if my length is x, my width would be half of that, or half of x. Okay, some of you might view this in a different way and say, well, can I just do x and 2x? Sure, but I think the majority of us understand this way a little bit better. Even though it is a fraction, who cares at this point? Okay, now we're dealing with area of a rectangle. And I'm pretty sure that you guys know that area is equal to length times width. And our area is 34, so let's just start substituting. Is equal to our length times our width. Okay, some of you might even want to use parentheses here. But regardless, what we're going to find out is we're multiplying x times x. So half of x squared, because x times x is x squared. Now I don't want that yucky or fraction, decimal, whatever you want to call it. So let's multiply by its opposite to get that form of 1. But if we're going to do this to one side, we must do it to the other. Okay, so 2 times 34 ends up getting us, what is that? 68 is equal to, well, 2 times a half is 1. So I'm just left with 68 is equal to x squared. And I love this because I don't have that middle term. I can use inverse operations. So let's take the square root of both sides to get x completely alone. And then what is that song that Mrs. Hayes sings? When you take the square root, you do something with a plus or minus. I don't know. I forgot what she said in between there. But we have to make sure that we take both the positive and the negative square root. Okay, what am I doing? I'm trying to click and talk at the same time, and that's not working. I just need to take the square root of 68 here. And I get, I'm just going to write it like this, x is equal to positive or negative 8.246 62, where'd my screen go? Here we go. 6211, and so on and so forth. It's irrational. That's why it goes on and on forever, no repeating. And we need to round to the nearest tenth of a foot, but we also want to keep in mind that we're dealing with feet here, so we don't care about the negative value. So we'll reject that one. And our final answer is going to be x is equal to 8.2 feet. Now that is our length here, right? Because our length is 8.2 feet. So I guess I probably shouldn't box this in because that's not my final answer here. I almost made a silly mistake, but it's a good thing I'm rereading the question and checking my work like you guys are doing. So this here is my length. But up in the question here, it says determine the width. So if the length is 8.2, we want half of it. So divide it by 2 or multiply it by 1/2. Either way, we are going to say the width is 4.1 feet. Okay, so question 3. Take a minute, pause the video, read the question, and graph this on your graphing calculator. That's all I want you to do. So go ahead and do that now, then pause the video, and then come back. Okay, so here we have basically what we're dealing with here is a football player is kicking a football, and this is a path that it's following. And when you look at the equation, some of you might have gotten confused when you saw the graph because you saw that it was a quadratic, it was an x squared. We're supposed to be looking at a giant upside down u, but when I graph this on my calculator, it looks like a line. So what on earth is going on here? Well, the thing that we really need to be mindful of, not only do we have to worry about graphing the function, but we have to worry about the domain. So from 0 to 150. Well, that's a problem because we're going from -10 to 10. So let's change this to, I'm going to go all the way to 160 to see if that helps. Ah, it's looking a little bit better, but notice how 6 is not high enough. So let's try 50. 50 works. Okay, so now you can see a nice clear picture of our parabola. And this is what you always want to do. You want to see a nice picture of it. Now, in order to graph this on our graph, the one thing that you don't want to do is this. Oh yeah, cool, looks great. No, that's wrong. We can't graph functions if it does not have points. So we always have to create a table of values. You know where to get this from. Control T. And we're graphing from 0, so we have to go backwards in our table. All right, so let's create our table of values off to the side. X and h of x. And we have to go from 0 all the way to 150. Well, that's going to be awful if we have to put 150 points. So I'm definitely not going to do that. Let's pick our points carefully. So 0, 0 looks like a good one. But check out all those decimals. Gross, 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 gross. Let's find, there we go, an integer. So I'm going to bring that over here. 15, 9. And this is a parabola. So I am looking for that vertex so I can maybe cut my time a little bit short scrolling on my calculator. Well, my guess is if I went from 0 to 15, I'm going to go from 15 to 30 because I'm counting by, there we go, counting by 15s. So 30, 16, go on, go on, go on. 45, 21. We're going to keep going with that. See if we can find our next integer. 60, 24. Oh, still not seeing that vertex because my numbers haven't gone back down again. 75, 25. Ooh, it's starting to slow down. I'm guessing that maybe that might be the vertex. Let's see. If our next point is 24, which it is, we found it. So 90, 24. Okay, now following that same pattern, why don't you finish the table? Now remember, the y values are just going to repeat in the opposite order. So that's where I got all those from, and then we're counting by 15s with the x value. All right, so here's my completed table of values. You can see on my calculator something weird is happening. So it looks like 1e to the -12th power. We are smarter than our calculators at this point. We are not going to write that in there. That's really 0. So this is scientific notation. 1e to the -12th just means move that decimal place 12 spaces to the left. So it's a really, really teeny tiny number like 0.000000001. So it's really 0, and we know this because it follows this pattern in our table. Our calculator is just doing some weird rounding. Okay, so now we need to graph this. Well, here's 0, 0, and I think I'm going to be able to count by 2s here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and then maybe by 5s here. So 5, 10, 15, 20. Go ahead and finish labeling yours. Okay, so here's the label. Then pause the video and go ahead and plot all of the points. Okay, so here is our graph of h of x. And notice how I plotted every single one of the points. I didn't leave anything floating, especially on the axes. That's very important. So on my x-axis, I have 0, 0, and also 150, 0. And somehow this got cut off here. So that's 150, 0 on my table. Okay, so determine the vertex. Well, that's the point where everything turns back around. That's a point 75, 25. So let's list that here. So we are going to determine it. 75, 25, and interpret the meaning in terms of the context, which means we need to use words. So 75, is this yards, feet, feet? Okay, so after 75 feet horizontally, the ball is 25 feet in the air. So the explanation would be the maximum height of the football is 25 feet when it is 75 feet away from the kicker on the ground. Notice how I talked about the football, I talked about units. You have to discuss all these things when it says in the context of the problem. Okay, last part. The goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough? I think that should say kicker. Will the ball be high enough to pass over the goalpost? Okay, and justify. So 45 yards. The first thing that we need to be careful of is everything in our problem is in terms of feet, and they just said 45 yards. So let's multiply 45 times 3. Oops, I wanted to add a calculator. So 45 times 3 ends up giving us 135 feet. So they're discussing the point 135, 9. And the goalpost is 10 feet high. Uh-oh, so this is a problem. Will the ball be high enough to pass over the goalpost? No. Why not? Because at 135 feet, the ball is 9 feet high. You could even go a little bit further and say it will miss the goalpost by 1 foot.